iC-Haus has launched ICT W39, an innovative 24-bit on-axis type SoC for magnetic encoder. I will demonstrate measuring the accuracy of a magnetic encoder using the ICT W39 evaluation board. This is a magnetic encoder SoC optimized for small BLDC motors applied to actuators of service robots and intelligent robots. The accuracy error ranges from approximately -0.067 to +0.078 degrees, so the accuracy of the encoder produced with the ICT W39 evaluation board is 0.078 degrees. Typically, the target accuracy of an on-axis type magnetic encoder is 0.1, but it can be seen that it is very accurate. In this video, I will review the accuracy measurement results at various speeds and compare the accuracy with another commonly used magnetic encoder product. In the next video, I will explain the increase in accuracy error due to the mechanical assembly error of the PCB and the accuracy compensation function of ICT W39. The product name is ICT W39 and the product description is a 24-bit magnetic on-axis angle sensor. While most products use Hall sensors, the feature is that Tunnel Magneto-Resistance TMR sensors are used to improve resolution and accuracy. As an on-axis type, it generates a one-cycle analog signal by sensing the magnetic resistance of a permanent magnet in one period per mechanical rotation and can interpolate it with up to 24 bits and output it as serial communication or incremental pulses. In the case of incremental output, a maximum of 65,536 pulses or 262,144 counts can be output per revolution. Those of you who have used an on-axis type magnetic encoder SoC may have experienced this, but the important thing is not 24-bit resolution but accuracy and jitter. By using TMR sensors compared to Hall sensors, I can improve analog signal quality and increase encoder performance. For further information, please refer to the catalog or contact ExactTron. The test equipment consists of the ICT W39 evaluation board, a permanent magnet scale sold by iC-Haus, a high-resolution optical encoder as a standard for absolute position, and a jig and servo system for rotation. Accuracy was measured by comparing the two encoder signals using the synthesizer, a dedicated encoder tester manufactured by iC-Haus. I will upload a video on how to measure detailed accuracy next time. This is a rotating jig with a test encoder using ICT W39 and a reference encoder connected. The two encoders are connected using a coupling with low backlash, and since measurements are made while driving at a constant speed without changing direction, there are almost no errors caused by the coupling. The shaft of the servo motor and the axis of the two encoders are connected and rotated using a flat belt. The following video measures accuracy. While the magnetic encoder using the ICT W39 evaluation board uses one cycle of analog signals per mechanical rotation, the reference optical encoder outputs 4096 cycles of analog signals, and has a built-in bearing to ensure accuracy. This is suitable as a standard for evaluating the accuracy of magnetic encoders. Let's measure the accuracy and jitter of the encoder using the ICT W39 evaluation board. Before demonstrating, let us first briefly define accuracy and precision. The definition of this is defined in the following graph if you look at the ISO standards referenced on Wikipedia. Accuracy is how close a given set of measurements, observations or readings, are to their true value, while precision is how close the measurements are to each other. Precision includes repeatability, the variation arising when all efforts are made to keep conditions constant by using the same instrument and operator, and repeating during a short time period. What I measure in this video is accuracy. I measured accuracy while increasing speed from 500 to 3000 revolutions per minute. I measured about 2 minutes at each speed and played at 4x speed. First, this is the accuracy measurement result when rotating at 500 revolutions per minute. This is the result of measuring accuracy at a rotation speed of 1000 revolutions per minute. There is not much difference compared to when rotating at 500 revolutions per minute. In particular, the accuracy error did not increase particularly when accelerating from 500 to 1000 revolutions per minute. This is the result of measuring accuracy at a rotation speed of 2000 revolutions per minute. There is no significant difference when rotating at 500 and 1000 revolutions per minute. Lastly, this is the result of measuring accuracy at a rotation speed of 3000 revolutions per minute. Even if the rotation speed increases from 500 to 3000 revolutions per minute, there is no significant difference in accuracy. The accuracy error ranges from approximately -0.067 to +0.078 degrees, so the accuracy of the encoder produced with the ICT W39 evaluation board is 0.078 degrees. Typically, the target accuracy of an on-axis type magnetic encoder is 0.1, but it can be seen that it is very accurate. In particular, you can see that the accuracy does not change significantly even when accelerating. If you look at the jitter, it is about 0.8 small divisions on the y-axis in the graph. Since one large division is 0.088 degrees and there are 7 small divisions in one large division, the actual jitter is 0.088 divided by 7 times 0.8, which is about 0.01 degrees. The following are the measurement results of another company's on-axis type magnetic encoder, which is widely used in robot actuators. What you need to pay attention to is that the ICT W39's y-axis is -0.35 to +0.35, while the y-axis of the magnetic encoder for comparison is twice that of -0.69 to +0.69. Since the y-axis scale is half, the accuracy of the ICT W39 is much better than looking at the waveform in the graph. The accuracy of magnetic encoders for comparison is about -0.25 to +0.26. If you look at the jitter, it is 0.025 degrees, about 2 small divisions on the y-axis in the graph. This is consistent with the iC-Hause results showing that the signal of the TMR sensor is approximately 2 to 4 times more stable than that of the Hall sensor. Until now, on-axis type magnetic encoders had the disadvantage of causing vibration when driving the motor due to jitter and low accuracy of the encoder signal. For encoders using ICT W39, the amount of vibration was reduced by about 60% and the accuracy error was reduced by about 70%, improving performance by more than twice. In addition to improving accuracy and vibration, the maximum resolution of prior on-axis magnetic encoders is mostly 13 bits or less, but it can output up to 24 bits for serial communication and 18 bits for incremental. This can be applied to small joints of service robots, intelligent robots, etc. For additional information, please refer to the following video. It will be more convenient to watch the next video if you turn on the alarm settings. Thank you for watching. ExactTron.